In this video, the learner will use the ratio of the sides in a 30, 60, 90 right triangle to solve for missing lengths. So where does it come from? When an altitude of an equilateral triangle is drawn, the triangle is cut into two congruent right triangles. These right triangles are also known as 30, 60, 90 triangles because they will always have those angle measures. Through the discovery lesson in class, we found out the ratio of the sides is x for the short leg, x root 3 for the longer leg, and 2x for the hypotenuse. And this common ratio will always be the same for 30, 60, 90s. Because of that, we can use the ratio to solve for missing lengths in that triangle. A hint with these problems is to pay attention to what piece of the ratio pattern you're given. That's going to determine how you solve the rest of the pattern. For example, find the values of the missing sides here. We are given the 14, which is across from 90. So we have our 30, 60, 90, and we're given that 2x piece. So 2x is equal to 14. So to solve for x, we just have to divide by 2. So x is 7. X is across from the 30, and so the length of that short leg MN is going to be 7. Then just plug in x to x root 3. So the longer leg LM will be 7 root 3. In the next example, notice we're given MN, which is 2. That's across from our 30-degree angle, so that's going to be our x value. Notice if x is 2, then the 90 is going to be 2x, which will be 4, because 2 times our x value gives us 4. Then I just have to plug in the x value to the x root 3 piece of the pattern and get 2 root 3. So the longer leg LM will be 2 root 3, and the hypotenuse LN will be 4. In this example, I'm given the side that's across from the 60-degree angle. That is the x root 3 part of the pattern. Notice here that x root 3 part of the pattern is just 9. Do not add a root 3 onto that 9 because that's not part of our picture here. I need to be able to solve for that x value so that I can plug it in to my 30 and then to my 90. So I know x root 3 is equal to 9. To be able to solve for x, divide by root 3. So our x value is 9 divided by root 3, but we can't write it that way, so we have to rationalize that denominator by multiplying by root 3 over root 3. That gives us 9 root 3 over 3, which reduces to 3 root 3. So our x value across from 30 is 3 root 3. Now I need to take x and plug it in to 2x. So 2 times x is really 2 times 3 root 3, which gives me 6 root 3 for the hypotenuse. So our hypotenuse LN will be 6 root 3. MN across from 30 is 3 root 3. This is an example I'd like you guys to try. We're given the side across from the 90-degree angle. You need to find x and x root 3 parts of the pattern. In this example, we're given VT is 12. That's across from the 60. So that's your x root 3 part of the pattern, and you need to find x and 2x.